Welcome to the Weather Review, the podcast that takes you beyond typical forecast and storm chasers logs, delving into recent weather and climate occurrences you may have just seen in the news. My name is Gavin White, and I am your host for the Weather Review. This week's topic has been circulating quite a bit over within the climate community on Twitter, as well as various news agencies jumping on attention-grabbing headlines pertaining to this very topic. And a lot of this has come to light in talking about it this week with the development of tropical storms Bret and Cindy this past week. And this topic of interest is the abnormally warm Atlantic Ocean. So currently a good chunk of the northern Atlantic is experiencing sea surface temperature anomalies of upwards of 3-4 degrees Celsius compared to the 1980 to 2010 climatological averages. So the ocean's a lot warmer than it has been in recent decades past. This has been ongoing for a while, right? I mean, we know the ocean's been warming for a few decades. This is well documented, but it's becoming a bit of an issue this week because of how warm it is. This was discussed more within the weather community more at the start of the month, June 1st, at the start of the hurricane season, but currently the main development region of the North Atlantic Ocean, also pretty much known as the tropics, is currently as warm as what that region is typically in during August and September, which is the more active period of the hurricane season. And that statement alone, you begin to see why so many are making such a big deal about this abnormally warm Atlantic Ocean, why it's drawing the attention of different news agencies, why various charts are circulating and being retweeted on Twitter. It's grabbing the attention of a lot of people due to this. Currently here in June, the tropical part of the Atlantic is as warm as we would expect it to be later in the season, in August and September, in which more hurricanes, not necessarily hurricanes, more tropical storms and hurricanes develop. So there's three major thought processes behind this warming Atlantic, or at least our perception of why the Atlantic is so much warmer right now. Those processes are climate, meteorology, and oceanography. So I'm sure you can guess which one is much more covered in the news, right? Climate change is the topic of discussion. That's what you want to be talking about. That's what's grabbing the attention, at least within the younger generation. Everything's about the climate, about climate change. And the explanation behind that with this climate explanation is that ocean temperatures are rising, which we know this is true. This has been occurring for decades now. And when you're talking about climate sciences, warmer oceans typically result in a warmer atmosphere, right? They feed off of each other. A warmer atmosphere leads to more heat that gets entrapped deep within the ocean. The ocean's really good at storing heat. So if you have a warmer atmosphere, you have a warmer ocean. If you have a warmer ocean, it's giving off more heat into the atmosphere. And a feedback loop is created. And you can see how those that are persistent in using climate change as their explanation for everything would jump on this the moment they see, oh, the Atlantic is a whole lot warmer than it should be for this time of year. That's the climate explanation behind this. It's a feedback loop. It's all fed by climate change, and that's it. But we know that the climate and the atmosphere and the ocean is a lot more complicated than just one explanation, right? Yes, there's a climate factor to it. There's also a meteorological factor to this. There's also an oceanographic feature to this, component to this, I guess would be a better way to say that. It's a lot more than just climate change. Sure, this could be a part of it, but there's other things as well, right? The meteorological explanation is there is currently, or at least over the last few weeks, there's been a weaker subtropical high-pressure system in the northern Atlantic Ocean, right, in the subtropical region. So above the tropical region where hurricanes and tropical storms typically develop, but below where you start getting to the colder Arctic waters. And this weaker high-pressure system has led to weaker easterly trade winds. Now, these trade winds are coming off of Africa. They travel along the tropics. And in addition to this, these trade winds typically, they increase the upwelling of cooler water deep in the ocean, meaning that these trade winds, they're blowing the surface water westward. And as that water is blown over due to stronger trade winds, more colder water from deep within the ocean comes up to fill the space that warmer water just left. That's what the upwelling of colder water is. So trade winds, they increase the upwelling of cooler water. But right now, this weaker subtropical high-pressure system is weakening the easterly trade winds, not permanently, but just for the time being while this high-pressure system is in place. And with weaker trade winds comes weaker upwelling of cooler water. And if you have a weaker upwelling, you don't have as much cold water coming to the surface. You have a whole lot more of that warm, I don't want to say hot, but of that warm sea surface water just sitting at the top, not really being replaced by colder water, thus resulting in a much warmer Atlantic Ocean compared to historical records at this time of year. Now, I tweeted about this out on Sunday, just kind of my thought process of trying to interpret it, and this is the explanation that I'm currently favoring. But in addition to the weakened trade winds, there's also, at least as of right now, there's not as much Sahara desert dust being blown over the ocean to the west side of Africa as we have seen in years past. Dust is a very good reflectant of solar radiation. So if you have more Saharan dust over the ocean, you have more solar radiation being reflected back out into space, heating the oceans less. So we don't have as much for the time being, likely due to weaker trade winds. So that's kind of the meteorological explanation behind it. The atmospheric setup that has led to, that can help explain why we're seeing warmer sea surface temperatures in the Atlantic right now. And the third thought process that could help explain why we're seeing these warmer temperatures is the physical oceanographic explanation. And that is a physical science, and it encompasses the Atlantic multi-decadal oscillation, which in essence is an oscillation of warm and cool phases in sea surface temperature variability, and each phase typically lasts 12 to 40 years, which is a very large range. And this is a natural occurrence. It's been observed for quite some time. It does happen naturally. So how does this actually apply to this? Well, we've been in a warm phase since the mid-1990s. And while we are gradually approaching a cooler phase, and I would suspect within 1 to 2 decades we'd be looking at another transitioning back into a cooler phase, we're currently in a warm phase. And as anything with averages, different data sets, they can spike year to year. So this, I'm theorizing right now, but this could help explain why we're seeing such much warmer temperatures. Yes, we're in a warm system, so we'd expect it to be warmer than average anyways. But 2, it can just be a weird spike this year. I doubt it's going to continue next year. We're seeing, again, more anomalies this high that we're seeing this early in the season. That could help explain it this year. Additionally, with the Atlantic multi-decadal oscillation, it's known to lead to a higher proportion of weaker tropical cyclones that develop into stronger hurricanes during the warmer phases, which helps explain why we've seen an uptick in stronger tropical storms over the last couple decades. Additionally, it's known, the oscillation as a whole is known to obscure or exaggerate global warming. Now, this alone throws into question the whole climate argument that can be made for what we're seeing right now, because if you have this system which naturally warms and cools good chunks of the Atlantic Ocean every few decades, it's going to make the planet seem cooler or warmer than what it might actually be on historical average. Now, I'm not going to delve into the numbers behind this just because I don't have those at my disposal at the moment, but this is just kind of my thought process behind it. And you can look in the show notes for this episode. I'll include a graph that shows the historical phases of this oscillation, at least the ones that we're aware of. And you can see that we're clearly in a warm phase, and that's gradually approaching the cooler phase. So looking at these 3 major thought processes that each one can be used to explain why we're seeing abnormally warm Atlantic sea surface temperatures right now, climate meteorologically and wow, that's a tough word to say, climate meteorology and oceanography. Each one has a place, and each one is true to a degree. I would, in this particular circumstance, I would incline that it's a combination of the meteorological and oceanographic explanations. I see that as more of a physical science explanation. I mean, I'm studying atmospheric sciences in school. I'm going to be inclined to rely more on the physical scientific explanation to things rather than a more theorized explanation. So that's my take on what we're seeing right now. I'm sure climate change is certainly impacting it, but I don't think it's to the degree that many at least in the media, are trying to make it seem right now. They're over-exaggerating the effect that we're seeing, when in actuality there's a very sound physical science explanation behind it. Now, why has this been such a big deal? Well, we're at the start of the hurricane season. And the ocean, at least where tropical storms like to develop within the Atlantic, is as warm as it typically is much later in the hurricane season, when the hurricane season is typically most active. So that alone causes quite a bit of concern as to, are we going to see much more stronger storms come through? Are we going to see more tropical cyclones, more named storms, more hurricanes, more major hurricanes as a result of this? Those are all very valid concerns to have, and things that we would typically see in predictions if this was a normal year, except this 2023 is not a normal year. As I mentioned before, we're in El Nino. All right, NOAA has declared that conditions are present for El Nino. We are in an El Nino year. And El Nino is a hindrance to tropical cyclone development. Now, it's not going to keep them from developing. Obviously, this past week we saw tropical storms Bret and Cindy both form. But what it does is it prevents the storms from developing further, from growing in size and intensity due to increased wind shear. And what that means is while the Pacific is figuring out its new ordeal with El Nino, the jet streams act a little wonky as they're trying to sort themselves out with these temperature changes out west. As a result, we get a stronger wind shear coming from the west over to the Atlantic, which the wind shear is going opposite of what tropical cyclones move due to the Coriolis effect. It likes to move clockwise in the ocean. And you have this wind that's trying to blow it the opposite direction. So you have these two forces for this particular Atlantic hurricane season, which makes it very difficult to predict what's going to happen. You have an abnormally warm Atlantic Ocean, but then you have El Nino. El Nino is known to be a hindrance. The Atlantic currently is pretty much be fuel on the fire. So the current hurricane season predictions from NOAA and Colorado State University are as follows. NOAA released theirs late May, right before the season started. They're predicting 12 to 17 named storms, 5 to 9 hurricanes, and 1 to 4 of which become major hurricanes, meaning they're category 3, 4, or 5. Now, Colorado State University initially released their predictions in April, and they had 13 named storms, 6 of which became hurricanes, 2 of which were major hurricanes. And then on June 1st, they updated it with the development of El Nino and the warmer Atlantic. They updated it from 13 to 15 named storms, from 6 to 7 hurricanes, and from 2 to 3 major hurricanes. Their predictions are in line with NOAA's, so the two are in agreement, and both NOAA and Colorado State cited El Nino as a hindrance and the warm Atlantic as fuel for development. That's currently what we're working off of. We've had 3 named storms thus far: Arlene, Bret, and Cindy. I'm not going to make any predictions. This is not, I don't have the models and data available to make said predictions. Those are just the ones that are most available at the time. Let's now delving into these 2 tropical cyclones that we saw this last week. All right, Tropical Storm Bret and Tropical Storm Cindy. Now, Tropical Storm Bret was an organized tropical depression on Monday the 19th, and then developed into Tropical Storm Bret later, again on Monday the 19th. He reached max winds at 70 miles per hour on Thursday the 22nd. Now keep in mind, 74 miles an hour or higher is a Category 1 hurricane. So Bret was 4 mile per hour away from hurricane status. Fortunately, he did not reach that. He peaked at 70, and then he quickly weakened as his track stayed southward into the Caribbean rather than shifting up further into the Atlantic. Had he shifted up and further into the Atlantic, he may have just strengthened into a hurricane. They were originally anticipating it, but he stayed southward and actually dissipated this past Saturday, the 24th, in the Caribbean due to strong wind shear from the El Nino jet streams. So for right now, we can say El Nino wind shear 1, warm Atlantic 0. Now, Tropical Storm Cindy. She was an organized tropical depression on Thursday the 22nd, and she developed into Tropical Storm Cindy early morning on, I believe, Friday the 23rd. She peaked with max winds at 60 miles per hour on both Saturday and Sunday, the 24th and 25th, and then began to weaken since. Now, she was weakening due to, again, strong wind shear following the El Nino jet stream, according to the National Weather Service. So she didn't develop as strongly as Bret did. Neither became a hurricane, thankfully. But in this case, Bret was ever so slightly stronger than Cindy, at least in terms of wind speed. And then late Sunday night, the 25th, Cindy was no longer organized and thus dissipated into an open wave, again, per the National Weather Service National Hurricane Center. So far for this hurricane season, El Nino's wind shear has killed 2 storms, and the warming Atlantic has resulted in 0 hurricanes. Just throwing that out there, that as of right now, if this were to be a little sports match, El Nino is certainly beaten up on the Atlantic as we speak. So as I said earlier, this is a very exciting week, right? We didn't have our first bit of tropical action, but our first major bit of tropical action, as we had 2 named storms this past week with a early potential form, but that dissipated. For next week or so, they're not anticipating any more storms to develop. But this past week, we had 2 at the same time, which was exciting to see, and pretty odd this early in the season. I forgot to mention earlier, Bret was, I believe I saw it, he's the furthest, how do I put this? It's the furthest east that a storm has developed this early on in the season. So it's an exciting time right now with this oddly warm Atlantic Ocean, brewing up some of these storms early on, but then watching them dissipate as they face the wind shear as a result of this developing El Nino. It's going to make for a very interesting hurricane season these next few months. If you enjoyed today's episode, please consider leaving a rating so others who may be interested can also discover this podcast. Also, as I briefly mentioned earlier, I'm currently a student who's entering this type of media and platform for the first time. The first few episodes will be rocky as I work out the kinks in planning, recording, and communicating this content. So please, bear with me as I learn to navigate this new journey. I'm confident it's going to be worth it. And with that, enjoy your week and keep your eyes on the sky.